My presentation will not involve slides. I will be happy to show you the product live on IP Finder powered by SDN. We will not use the query builder or the viewer. We will use the regular command line interface, and that is because this database will require a lot of proximity operators and specific ways to make combinations that probably won't be easy to do when we are in the query builder or in the viewer. So let's take a closer look at this. And yeah, I'd be happy to take your questions. I have a second screen where I can also see your questions. If you do that to everyone or directly to me, dependent on your preference, then I would be able to see those. I will talk about the outline of the database, the structure, and its search options, both for SAR data, ADME, properties, and toxicology or toxicity properties. As well, we'll use a particular compound that has all of the three in a compact way. And then we'll go and take a look at what is called PROTACs. So these would be compounds that would degrade their targets. So we'll take a look at how to search for those. We'll take a look at ADME data in terms of finding specific half-life values, particularly those that are related to studies that were done in the liver. So that's a particular use case that we can use. We take a look at cytotoxicity, especially where rat or mice were used as the species. And then we'll take a look at a number of patents that claim combinations of different targets, and we'll see how CS Bioactivity is able to help us with those. In that example, we'll also see how to find the proper name for these targets that you want to search. So that may not always be directly obvious in that sense. We'll take another look at a combination. We'll take a look at searching for specific cell lines. Sometimes these cell lines are seen as kind of the target. A particular compound has been studied, how it reacts to certain cell types. So we'll take a look at that. We'll also take a look at searching for compounds that are active against microorganisms. We'll take a look at a fungus, an Aspergillus version of that, see how that would work. And then we go for an example to search for antibodies or antibody drug conjugates, especially also where they are bispecific antibodies. So that's coming. And if we have time, there's even a example for macrocyclic drugs if we have time to do that. So I better get started. And if you have requests for my transcript, I'll also be happy to provide that to any one of you who are on the call, or you can contact me later if you're listening to a recording of this. So first plan is to go into file CS Bioactivity and get familiar with the structure of the data. So I found a particular compound, and I'll use that with a CS registry number, and the registry number can be searched in the basic index to find the information of this compound in this database. Please keep in mind that the structure of this database is organized by what we call ligands. So active compounds that could be small molecule drugs, peptides, radio-labeled ligands, or indeed also an antibody drug conjugate. So every answer is one substance, similar to what we have in the CS registry file. Every answer is one particular compound. Within that record of the compound, we may have SAR data, which we can display by showing display SAR prop, and that would show kind of that information. So here we see the CS registry number, we see its chemical name with the CA index name, we see a INCHI string, an INCHI key, and we also see what is called property files. These are tags. Which of the three data sets are actually available for this compound? So this compound, which is why I took it, both has SAR properties, ADME properties, and toxicity properties. So here we're looking at the SAR properties. This is coming from two separate publications. So we have a total assay count of 3 for all of the across multiple papers and patents. We have an overview of 3 SAR data points where we would see the target name, and in this case it's tyrosine protein kinase LCK, and we would see that the table that is presented has the target name. It could have a target registry number, although that is probably the least systematic thing that would be in here. The target name is the most normalized entity that we see here. Then we get things like a function, which could be like an inhibitor, antagonist, agonist, degrader, as we will see later on here as well, modulator, and then we have the parameter, and here we see that it's also a DC50 or a DMAX, which is a degradation related parameter that is there. We see the value. The value was originally published as 5 nanomoles, but we normalize everything back to mu-moles or micromoles, so that is given in a normalized value there. I have to say that the value is not numerically searchable, but we hope that we are able to add kind of a p-value, which would be a more simpler component entity where we could look for an indication of the activity that we could add. If the document also lists the disease, we see that. We can see the organism in which this was tried. And then when we click on the assay details, we can see further information that is there. We have fields like assay type, assay procedure, the disease, the cell type. This was not in the table originally. Is this in vitro or in vivo? So this SAR biotype allows you to quickly identify if this is in vitro or in vivo data that was captured. Here we also see the WO reference with the CS accession number. We have a locator information as well. So this would be what is the description of this ligand, this compound in this particular publication. So there's compound 46. And if we look at the second publication, which is JMed Chem, where it is compound number 7, where we also have some of this data there, which you see here as well. Some data is given in percentages, some data is given in micromoles. So this doesn't make a very systematic way of searching for that. So that is available. Actually, when you look at your transcript of this session, you would see that this is not given in a table, but it's actually a tagged data field, more similar to what we saw in that assay summary, that would have every field clearly indicated, and then the content of that field is provided. So it is easier to post-process this and extract the data directly out of that transcript. Let's have a look at the ADME properties that are available here as well. So for the same compound, in this case from one of those publications, JMed Chem 2024, again substance number 7, we have a T1/2, so this is a half-life value indicated in hours, normalized to still hours, and then we have the ADME assay detail that was also published in this way as well. And we can see, for instance, the ADME ligand dose, which was again data that wasn't clearly provided in the information in the table, but in the assay details that is provided for. And then finally, also looking at the tox properties, and those would give them data from the WO document, where there is apparently some data that was published there was related to some sort of toxicity information against certain cells. Yes, of course, this was done in vitro, and we can see also the names of those assays. All of these fields are actually searchable, and all of these fields are also searchable in the basic index. So if you just want to search for a glow assay, you don't have to think about, well, in which of these search fields, what is the field code for that. You can really just search it in the basic index as well. But otherwise, help search field is, of course, the main guideline to see how you can find information. So we have different fields for the toxicity part, we have different fields for the SAR part, and we have different fields for the ADME part. So it looks like a lot of alphabet soups, but there is certainly a good logic to that. And then furthermore, on the identification of the substance and also field availability information, which will be helpful as well, as we will see that a little bit later on. If you go to CA+, where of course the references that we've looked at come from, there is a general crossover from CS Bioactivity to CA+ for all of the publications. So here I cannot be specific about the publications that are connected to a particular assay or a particular data point, but if I simply search L1, I basically get 2 hits in CA+. Those would be my JMed Chem article as well as the WO patent that would be certainly available. And we have added a few pieces of information to the field availability field in CA+. So there you would find how many documents have we curated for the ADME data. And obviously, if we scroll further, we can see the same for the SAR, so about 500,000 publications. And then for toxicity, it's a little bit less, around 30,000 documents have been identified for this. Please also consider that CS Bioactivity is a database for human medicine, so therapies that would be related. So you do not find information on the toxicity of industrial chemicals like benzene. So that is not the scope of CS Bioactivity. That is purely for human therapy compounds that have been identified. When we search on a CS registry number, and I can certainly do that here in CA+, I'm still in CA+ here. So if I search for a registry number, I may get more answers. There is also a different search field in in CA+, which is RN Bio, and this would specifically look at has this registry number of a ligand been identified in the publication in CA+ for either its ADME, its toxicity, or its SAR data. So that is what is available in CA+. And similarly, in registry, we have the locator field that indicates that that compound has a record in CS Bioactivity, and that's for about 5 million compounds there. Okay, let's take a look. We go back to CS Bioactivity. I usually just use file CAS Bio as the shorter version of that. And let's take a look at the information around protein degraders or PROTACs that are available. So most of those would have either a DMAX or like a DC50 or DC90 or DC10. So I can basically use two exclamation marks that would then indicate I have two more characters for this. And I can also use the word degradation or degrader, degradat, I'll use this, or degrad, and truncate. And we have a number of search fields for this. One is either the SAR parameter, and this would be SPAM, and the other would be the function field, which is SAFN. And so we can look at both of those. We see that that some things are really more normalized, that the parameter is indeed DMAX, that is not a function, but the word degradation or degrader is certainly a function. So this is how this kind of brings together this information. And we could actually also look at the basic index to find even more data, because then it could also be part of, let's say, the data which is related to maybe the description of the assay where degrader or degradation was mentioned in that sense. Display hit is definitely your friend in this database. So let's look at a few records: answer 1, answer 100, and answer 1000 in the hit format. So here we see that we get different substances, each with a number of SAR properties, in this case 2. However, only one was either connected to degrader as the function or DC50 as the parameter. Here we see also degrader as the function. And here we have Emax as a parameter, which we could add as an option. And here another one that would have further details to this. And then we see which of those target names would be listed. Good. We could also use the parameters for the ADME data. So we saw already from our first example that there was this T1.5 option to look for half-life. So we can certainly search for that. T1/2, and the proper field would be the A for ADME. And then it is in the PAM field, the parameter field, which we can search. So this finds 77,000 different ligands. And when we want to combine something which would connect different components of the record, but within the same line of the table, within the same measurement point, we would always use the P paragraph operator for this. So we can use L7 and then P for making sure that whatever I'm going to connect with is actually searched in the same data element, in the same measurement. So there I can say I'm interested in the half-life in the liver. So that should be the ADME organism. So that would be the AORG field if we look at that. And there is also the ADME procedure text, which may also indicate that some cells from the livers were used. So that would be AAPR as a search field. And we can then take a closer look at this. So display hit. Let's see what we get. Indeed, we have a half-life for this particular compound. And then here we would see that we would have a particular assay, and in this case, it is indeed in the assay procedure that it says in human liver microsomes with this, the half-life was determined by a particular method. So that is something which we can use. Or again, you could say I'll search L7P and then simply use liver. in the basic index, which may even get you, I don't know, a couple of more records where, I don't know, the word liver, we could get liver in the disease area, which is maybe not desired, but you can decide if you want to go for recall or for precision. That would be perfectly fine. It looks like all of you are still following along, and it's either entertaining enough or you're saving your questions for a little bit later, but do feel free to ask your questions here as well. Let's look for the toxicity data, and one of the options that a lot of organizations are interested in is cytotoxicity. You can certainly use terms also in an expand command, but let's do that actually. Expand cytotox in the field. We could indeed do the basic index, or we could use T for toxicity and then parameter. This would be a parameter that would be there. So we see that there's cytotoxic and cytotoxicity. Cytotoxicity is certainly the larger item, but we can also certainly use cytotoxic and then truncate for the field TPAM for the toxicity parameter. And when you do a further browse of the information, you also find that there is an option for cell killing. Sounds very brutal. That is also a T parameter, a toxicity parameter. So we can use that, but we get a few more on cell killing, but that would be a possibility here as well. So for this one, I want to use this in mice or rats. And within CS Bioactivity, all organisms have been standardized to their scientific names. So if I want to combine, please remember the P operator is your friend here. So that would be mus or ratus in Latin for mouse or rats. And we have a possibility to use the toxicity assay organism. That would be the most likely field for this. And so let's have a closer look. We see that it is indeed narrowing down the studies a little bit. Cell toxicity is the original description in this journal article, but we normalized it back to cytotoxicity to have more standardized terminology. We see a percentage value, inflammation as a disease, and then mus as the organism. And we can provide, again, the overview of the assay details, which will be automatically stored in your transcript. So don't worry about that. We see also that it's possible to search for cell types. We'll see that in a slightly later example as well. I would be interested to see what kind of other parameters might be available within these particular records, and even look for all of that there as well. So if we would indicate if studies in rats, so ratus or mus as the toxicity assay organism, TAOR, that would be linked to any kind of TPAM as the field availability. We could then see what other records would be retrieved. Ooh, what did I do wrong here? I forgot a space between the search and the brackets, so that would be fine. As you can see, it is all live. So here we got 125,000 that is there. So that is indeed a large answer set. I'm not going to analyze all of that, but now that we have, let's say, our parameter searched as a field availability, it means that that parameter becomes a hit item that is linked to either mouse or rat. So I can do an analyze command, and I'll not do this for a very large number. Let's take 1,000, and then we'll use hit TPAM as the field that is used here. So I made sure that this field is highlighted by searching the field availability, but we can then do a quick overview of the content of that field by doing an analyze command. There we go. It's even faster than that. And here we see, let's just display the first 10, but we see that we get we get original terms, and we also get normalized terms. So apparently in the first 1,000, LD50 and LC50 are the most common ones, but we can see also other ones. So if we want a larger one, let's say the top 20, and here I would really prefer to limit my analysis list or my display of the analysis to those that would actually have that word normalized, to just make sure that I'm only looking at the normalized values, not the free format values, so to say. And that would give me then a nice overview of all those types of things that are there. And here we see our cytotoxicity, and we also have some other ones there as well that would be available in this database, specifically linked to the first 1,000 records of mice or rat studies in toxicity. Okay, let's move a little bit to a particular search. So I found a particular patent, and you do have the possibility to search for a specific patent in here. So we have WO225 and then 186320, and we can search that in the SAR reference field. So that should give us, oops, why did that not work? No, that then I will take a closer look at that. I may have a typo in there, but otherwise, oh, there may be A1 or something behind it. No, okay, then that was a little bit of improvisation. Then I will take that out. What is really important, we could look at the CA+ record, but this patent claims a combination of a beta-2 adrenergic receptor agonist and an SGLT2 inhibitor. So kind of a co-administrative administration drug combination that is there. And so let's have a look. We can search for beta-2 adrenergic receptor. Okay, and we search this in the STNM field. This is the SAR target name field, so that's what would be the most likely option where this would be found. And we see that that is bringing back a good number of results. We also see that this search field is actually a word-bound search field. So that would mean that that it searches for the individual words and then combines it with a default W operator in here. So this gives you a nice possibility, for instance, to look for all tyrosine kinases, irrespective of its subtype, and that has some advantages as well. So we want one compound that has this activity, and this should be an agonist. Do not search for the word agonist in the STNM field, because the agonist is actually the parameter, or the function of the target. So let's use L17 We'll use the P operator to make a connection within the same measurement. And here we want to have agonist in the same measurement. We can certainly include the function field, SAR function field, and that should give us a smaller number of ligands that are not inhibiting but actually activating or agonisting these particular types of records. So let me do a display hit here. So we see indeed beta-2 receptor agonist. We see a particular value there for inflammation, and here we have our substance. So we are able to identify these 6,000 compounds. Let's do the same for SGLT2 and search that also in the STNM field. And we will see that we only get 4 records, which isn't very promising. So let's go to the registry file where this target probably has a registry record. Search SGLT2 as the chemical name. And we would see that we actually have a record for this target. And here we can get a little bit an idea what is the terminology. So the SGLT stands for sodium-dependent glucose transporter or glucose co-transporter. I saw that here as well, glucose co-transporter 2. So in this way, we can either transfer these names, or we could go back to CS Bio and use that to find our compounds. So we search for sodium, and if I want to be more flexible in terms of how these words should be combined, I can certainly use the S operator within that. So sodium, S, and then glucose, that should be there definitely as well. S, and then either transport or co-transport. Co-transport, yeah, no typing errors so far. And then the S as well. And then we wanted to have number 2. And close that and search this in the STNM. And let's keep our fingers crossed. Yes, we get 4,000 hits. And let's do a display hit, which would show us certainly here sodium/glucose co-transporter 2. That is the normalized name that this target has in CS Bioactivity. So it is helpful to look for particular standardization in CS Bioactivity, which may be different from, let's say, the name of the target, either in the CA lexicon or in the registry file where an enzyme may be getting its systematic name for registry. So that is something to be a little bit careful about. We want to find patterns that mention both substances, ideally in the context of hyperglycemia. So we are going first to registry, and we're going to use first the transfer command for all the registry numbers for our beta-2 agonist. So that would be L18, and that would be our 6,400 ligands that CS Bioactivity was able to identify. So let's bring those over. And in the meantime, you have time to ask your questions. I do not see any questions yet, because you're very keen to follow along the steps that we're doing here. That is also fine. Yeah, 6,000 is going to take a little bit of time. Actually, for the sodium glucose co-transport 2, that should be an inhibitor. So let me just go back to CS Bio, because I forgot to add that to my query. So search L21, P operator, making sure that it's there, and then inhibitor as a function. So that would narrow down a little bit to 3,100. Go back to registry, transfer L24, the registry numbers for all of those. And then we have our two sets in registry. So L23, which is our beta-2 compounds, and then we will get L26. So with these, we could either go to CS formulations, or we can go to CA+. I'll do that. And then indicate a combination where we would have L23, L23 and L26. So that is quite a number of records. We want to find patents as a document type. That makes also quite a bit of difference. And then here L28 and hyperglycemic. We'll truncate there. Oops, hyper. There is, oops, I did a typing error, hyperglycemic. That looks much better. So in that way, we can find easily compounds where both of those would be provided. And that way we could obviously also look for instance, documents with, I don't know, a certain publication date, etc. So that would give us some capabilities. Yep, that would give us some options. Another example, now that we're here in CA+, I can also look for the patent here, WO. This is a different answer, 255.66.7 as the patent number. Let's have a quick look at that. Tried not to take patents from any of the possible attendees here. This is a university patent. So we have some derivatives that we could have, and therefore we wanted to take a closer look there as well, in a way that these compounds could be represented. And we see that these are listed as vitamin D receptor agonists, as well as histone deacetylase inhibitors. So I have a similar situation. In this case, the one compound has to be both an agonist for vitamin D receptors and also has to be inhibiting one of the histone deacetylase, the HDAC targets that would be there. So let's take a look. We go into CS bioactivity. Here we expand on vitamin D receptor ST and M. You see that both the individual words as well as the full phrase can certainly be used here. And we see that there's actually here only the identification of vitamin D3 receptor. And there is a good number of those in the database. So we'll search E41 as vitamin D receptors, and those should be the agonists. Let's make sure that that is there. That is indeed the agonist. So I'll use the P operator to combine it with agonist. You could also do this in the basic index. As I said, all of those terms are also available in the basic index. So this gets us 306. And then we can look for the HDAC. So expand HDAC in the STNM. And we see that that gives indeed a couple of HDACs here. So we may want to use some of those. Search HDAC. Probably truncation would be useful here. Yeah, HDAC as the STNM. That would be helpful with the search slash as well. But we can also look for histone deacetylase in the STNM. And I don't have to put a number behind that because it is also searching this word bound. So I'm getting the histone deacetylase 2, 3, 4, 7, etc. So all of those are included here. We want to have L33 or L34. Oops, 34. So that would add slightly something, and then these should be searched as inhibitors. So that would also be useful. Search L35P, and then inhibit as the SA function. So that would get a larger set, 47,000. So we'll combine our agonists in the first place. So that was the vitamin D receptor agonist in L32. And now you have a question. You want to combine that with the inhibitor for the HDAC, which would get 3 documents. Let's have a look. Display hit. Let's take the second one. Yeah, I have to say that there is unfortunately a defect with slightly more complicated queries. We are aware of this, and we will actually repair this as well. We can look at the total number of activities, and here we can see that it's really then not ideal to display all of the SAR count. But what is probably more important is to see which compounds these are. So we have then the possibility to see the register numbers and the names of these 3 compounds, and that's, I think, more interesting than maybe the actual data there. Good. I see we have another 15 minutes, so I would like to also indicate a few searches for finding, let's say, either cell types or also other pathogens. So when you would search for a pathogen, again, you would use the scientific name, Aspergillus, and then we'll take not the more common Niger there, but we will use the Brazilian version of Aspergillus brasiliensis. And I think I have typed it correctly. Let's see where this, no, I had one L too many. There we go. 564 hits that are there. And here we would see very often that we would have this either as a target name, or we may have this as a species, as an organism name. So in this case, it makes really good sense to search this within the basic index so that both of them would be retrieved. So yeah, that is probably helpful. And then we can combine this with a parameter, and probably one of the most common parameters is either the zone of inhibition, which occurs quite often. but we could also take a look at what are the typical parameters for analyzing these type of pathogens. So analyze L39, and then we would look at the SAR parameter field just to see what that includes. We could obviously also, and I think that would be a good idea, still link this to make sure that the parameter that is analyzed is the parameter that is connected to this Aspergillus version. So we'll take L39, use the P operator to connect it with the spam/field availability. So that would make sure that this is highlighted, and then we analyze L40 for the hit spam, and there is a space for that, and we have 500. That should be doable. Good. And we will see then from the results that we get indeed the zone of inhibition, and we'll also get things like MIC, which is a parameter that is very often used for these types of options. I think we have probably a couple of records with very many data points. So let me use the break here to interrupt this just to conserve time. Okay, we have a couple of answers here. So let's take a look. Yeah, MIC, IC50 zone of inhibition, etc., and a couple of other typical parameters that are associated with these types of pathogens. Let's take a look at what information CS Bioactivity has for antibodies or antibody-drug conjugates. And to identify those, we would have to go to the registry file. So in registry, we would have two ways of searching, or actually three ways to searching antibodies. They usually start with immunoglobulin something, and then a little bit further in the text, a few words apart, there is the word anti. Which is there, and that usually indicates an antibody. So a systematic name for an antibody would start with that, and to identify antibodies, we would be able to use this option. Commercial antibodies usually, not always, but usually, typically ends with some sort of MAB, MAB, monoclonal antibody. Unfortunately, we cannot do left-hand truncation on MAB. We have to use 4 characters at least. So I'm going to use AMAB or $EMAB or $IMAB or $OMAB or UMAB. Is there anything else? Maybe there is YMAB here as well. And I'm using this obviously in the chemical name segment field. That would give us sort of the names that would end with one of these options. So that is there as well. And the third way that you can search for antibodies is when the antibody is not defined, not in its function, not in its sequence, but in that case only by its trade name, and those would then have the word antibody in the editor notes field. So that would find, let me show you an example, that would find something which has a trade name CT107, a humanized anti-PD-1 monoclonal antibody used for cancer immunotherapy by this company. And there is indeed a reference for that antibody which is listed as a trade name. So the editor notes fields to provide more information around this trade name is a useful search field that we can use. So that is very helpful. So we have search L32 to L44, which would combine all of that with OR combinations. And of course, for these, we would really need a lot of time to cross over 300 and 3000. But when we combine this with CS Bioactivity in the locator fields to make sure that any of these antibodies would have data in the CS Bioactivity database, we would see that we are left with 5,200 antibodies, and we can then certainly take this over into CS Bioactivity. For transferring between registry and CS Bioactivity, unfortunately, there is no L number crossover, so we have to use the transfer registry number of L46, and that should be possible. So we would also have the possibility to go back to registry if we want to look for bispecific antibodies. Those would have 2 times the word anti as a name segment in the name of the description of the antibody. That would also give us some capabilities here as well. Display SCMT, how much data is there available for the first 5 answers? That is very reasonable. So display SAR prop for the first 3 would show us at least some of those data. So in terms of the name, you would find indeed the antibody trade name. We would have data from journals. We can see which one have connections to a particular target, like interleukin 17, which is there, and we can certainly take a closer look at those. So if we want to see which of these antibodies, for instance, have connections to CD3, the antigen there, then we can use that in the SDNM field to find antibodies that have data for this particular antigen, for instance, or its glycoprotein, which is there. Good. I still do not have any particular questions, but I would like to hear from you. And I do see that also I have quite a few colleagues from our IP services group. Feel free to send me also in the chat, either direct or for everyone, I know your first impressions of the database. If this is something you feel that you would use on a regular basis or an incidental basis, that is certainly a possibility. For those of you from industry, please keep in mind that if you feel uncertain about this particular new database with lots of new capabilities, you can obviously always contact our help desk at help@cs.org, or you could also choose to outsource your search to our IP services group. That is obviously also a possibility. I see some direct messages coming in. So that is, how can you search bispecifics? Yes, I can show you that. So file registry, search, and I'll use my original search here in L42, immunoglobulin anti. So I can search that already, L42. But I want to make sure that anti as a chemical name segment occurs 2 times. So I'm using XW, which means there is an infinite number of characters or words in between those 2 terms. And it will make sure that those 2 terms cannot overlap. So let's take a look here. Display IDE. So we can see here immunoglobulin G1, human, and then we get part of the chains, a fragment, fusion protein with, and then here we get anti. So this is anti-human interleukin 4 receptor, but also we get here protein, fusion protein with, still the same. So you would probably want to remove things like fusion proteins because they may have the two components as separate entities. So let me see. So here, search L50, not fusion protein. Display IDE. So here you do see that also the word bispecific is here, but usually there is an indication of anti, and you have your first target, and then further in the name, you have another anti, and then here we have the other target, which is there. So the fact that I have two occurrences of the word anti or the word bispecific in the immunoglobulin, immunoglobulin in the same sentence as bispecific is also an option. So that would give us a good number of hits. But the approach that I had here, L51, not L52, or we could also OR them together, does have unique capabilities as well. So we probably want to combine with OR, L51 or L52, 7700, and those should be really good results that would be there. So immunoglobulin anti, D14, synthetic, bispecific, and then we have that as well. So both the bispecific and the 2-time occurrences of anti would get you your bispecific antibodies. Hope that answered your question, Craig. Good. I see we are at the top of the hour, but I hope that this was at least a good first impression of CS Bioactivity, and that this at least has sparked your interest in what this database could do for your searching.